Hello good people, I'm going to tackle this enthalpy of formation problem. So it says, calculate the enthalpy change when 10 grams of nitroglycerin is detonated. Use the enthalpies of formation given below. Well, first things, I'm going to circle this 10 grams because I have a feeling it's going to be important later on. Okay, I'm also given this reaction equation down here. So in order to figure out the enthalpy change for 10 grams of nitroglycerin, I firstly need to figure out the enthalpy change for this reaction. How do I do that? I will need this formula. So this is the formula we use when we are trying to calculate the enthalpy changes using enthalpies of formation. So we need to sum up all the enthalpies of formation of the products and then subtract all the enthalpies of formation of the reactants. Let's see what we have here. I'm going to start with the products first. So we have nitrogen. The enthalpy of formation for nitrogen is given as 0 kilojoules per mole. Next, we are given oxygen. And the enthalpy of formation for oxygen is given as 0 kilojoules per mole. Next, carbon dioxide. Its enthalpy of formation is given as negative 394 kilojoules per mole. And finally, on the product side, we have water, and the enthalpy of water in its gaseous state is given as negative 242 kilojoules per mole. So that takes care of the product side. On the reactant side, we have just nitroglycerin. So that is C3H5 NO3 3, and the enthalpy of formation for nitroglycerin is given as negative 364 kilojoules per mole. Let's use the formula. So the enthalpy change for the reaction is the enthalpy change of nitrogen, or let's do it the other way. So number of moles of nitrogen, which is 3, times the enthalpy change, sorry, not the enthalpy change, the enthalpy of formation for nitrogen, which is 0 kilojoules per mole, plus half a mole of oxygen times 0 kilojoules per mole, plus 6 moles of, and I should actually write mole, of carbon dioxide. Sorry, 6 moles times the enthalpy of formation for carbon dioxide, which is given as negative 394 kilojoules per mole. And let me just add, so this is 3 mole, and this is 1/2 a mole. I'm writing the units because they're important for later on, you'll see in a moment. Plus 5 moles multiplied by the enthalpy of formation for water, which is given as negative 242 kilojoules per mole, minus, well, we have 2 moles of glycerin, pardon me, 2 moles of nitroglycerin. So 2 mole times the enthalpy of formation for nitroglycerin, which is negative 364 kilojoules per mole. So a couple of things. This mole and this mole will cancel. These guys will cancel as well. So moles will cancel. And we will be left with kilojoules only. So 3 times 0 is 0 kilojoules. Plus half times 0 is also 0 kilojoules. Plus 6 times 394, and I'll do that on the side, is negative 2,364 kilojoules. Plus 5 times negative 242 is negative 1,210 kilojoules. So that takes care of the products. Let's look at the reactants. It's 2 times 364 kilojoules. So that's 728. 700, oops, that is not correct. It is negative 728 kilojoules because I have multiplied 2 times negative 364. Now we have 0 plus 0 is 0, minus 2,364, minus 1,210. Pardon me, let me just do that quickly on my calculator on the side. So I get negative 3,574 kilojoules. So essentially what I have done is negative 2,364 plus and a minus make a minus, which means it's negative 2,364 minus 1,210, which gives me negative 3,574 kilojoules. Minus negative 728 kilojoules. Minus and a minus make a plus, which means I have negative 3,574 kilojoules plus 728 kilojoules. And that gives me negative 2,846 kilojoules. Now, after such a lengthy calculation, you may go, fantastic, I'm done. Well, no, you're not, and I'm not. Because what have we calculated here? We have calculated the enthalpy change for the reaction. And if we look back at our reaction equation, it involves 2 moles of nitroglycerin. In other words, we have calculated the enthalpy change for the detonation of 2 moles of nitroglycerin. Let's figure out what the enthalpy change is for 1 mole of nitroglycerin. So this is for 2 moles. In order to figure out what the enthalpy change is for 1 mole, we need to divide negative 2,846 kilojoules by 2 moles. And we will get 1,423 kilojoules per mole. Are we finished? No, we are not, because now we have the enthalpy change for 1 mole of for 1 mole of nitroglycerin. The question at the very start asked us, what is the enthalpy change when 10 grams of nitroglycerin is detonated? That means that we need to figure out what is 10 grams in terms of moles. And I'll do that on the left-hand side here. So the formula is N, number of moles, equals mass divided by molar mass. And I'm going to use symbol MR for molar mass. Well, what is the mass? It is 10 grams. That is what we are given. What is the molar mass, or pardon me, the molecular mass for nitroglycerin? Well, we need to figure that out. And we're going to do that by using the formula that is given to us. So I'll just copy this and bring it down here to figure out the molecular mass for nitroglycerin. And I'm going to use rounded values for the molecular masses of individual atoms. So we have 3 carbons times 12, because 12 is the molecular mass, sorry, the molar mass of carbon, plus 5 times 1, plus 3 times 14, plus 9 times 16. So this 16 is the molar mass of oxygen. 3 times 12, 36, plus 5, plus 42, plus 9 times 16, 144. All of that together is 227 grams per mole. Okay, so that is the molar mass, the molecular mass for nitroglycerin. I can use that value in this formula here. So now we have 10 grams divided by 227 grams per mole. Moles and moles will cancel. Sorry, grams and grams will cancel, and this mole will come up on top, which means I have 10 divided by 227. That is 0.044 mole. I have not pulled that number out of my head. I have just quickly used the calculator on the side. And we are almost finished, because now we know we have 0.044 moles of nitroglycerin. Pardon me, nitroglycerin. Nitroglycerin. I'll get it right eventually. And I know, or we know, that the enthalpy change for 1 mole is negative, and I forgot to write a negative there, negative 1,423 kilojoules per mole. That means all that is left to do is to multiply these two numbers together. So 0.044 mole multiplied by negative 1,423 kilojoules per mole. Moles and moles will cancel, which means I will be left with kilojoules only, and that's fantastic. And we can say that is 62.6 kilojoules. So finally we can say that the enthalpy change for the detonation of 10 grams of nitroglycerin is negative 62.6 kilojoules. That is all for now, and I will see you on the flip side.